This week, we're going to try and demystify AI, ML, and DL. Artificial intelligence, AI, machine learning, deep learning are three terms often used interchangeably to describe softwares that behave intelligently. However, it's useful to understand the key distinction among them. You can think of deep learning, machine learning, and artificial intelligence as a set of Russian dolls nested within each other, beginning with the smallest and working out. Deep learning is a subset of machine learning. Machine learning is a subset of AI. And AI is an umbrella term for any computer program that does something really smart. In other words, all machine learning is AI, but not all AI is machine learning, and so forth. AI can be a pile of if-then statements or a complex statistical model mapping raw sensory data to symbolic categories. The if-then statements are simply rules explicitly programmed by a human hand. Taken together, these if-then statements are sometimes called rules engines, expert systems, and knowledge graphs, or sometimes symbolic AI as well. Collectively, these are also known as good old-fashioned AI. Machine learning is a subset of AI. That is, all machine learning counts as AI, but not all AI counts as machine learning. Let's take an example. Symbolic logic, rules engine, expert systems, and knowledge graphs could be described as AI, and none of them are machine learning. One aspect that separates machine learning from knowledge graphs and expert systems is the ability to modify itself when exposed to more data. That is, machine learning is dynamic and does not require human intervention to make certain changes. That makes it less brittle and less reliant on humans. The learning part of machine learning means that machine learning algorithms attempt to optimize along a certain dimension. That is, they usually try to minimize error or maximize the likelihood of their prediction being true. This has three names: an error function, a loss function, and an objective function, because algorithms have an objective. When someone says that they are working with a machine learning algorithm, you can get the gist of its value by asking, what's the objective function? Machine learning, in short, is an optimization algorithm. If you tune them right, they minimize their error by guessing and guessing and guessing again. Deep learning is a subset of machine learning. Usually when people use the term deep learning, they are referring to deep artificial neural networks. These artificial neural networks are a set of algorithms that have set new records in accuracy for many important problems, such as image recognition, sound recognition, recommender systems, natural language processing, etc. It is a field of science that gives computers the ability to learn without being explicitly programmed, and that tends to result in higher accuracy. It does require more hardware or training time and perform exceptionally well in machine perception tasks that involve working on unstructured data such as blobs of pixels or text. So what's next in AI? There are three main schools of thought on how people talk about AI. Those who believe that AI progress will continue tend to think more about strong AI and whether it's not good for humanity. Among those who forecast continued progress, one group emphasizes the benefit of more intelligent software, which may save humanity from all its current stupidities, and the other group worries about existential risk of a superintelligence. Those who do not believe that AI is making that much progress relative to human intelligence are forecasting another AI winter, during which funds will dry up due to generally disappointing results, as has happened in the past. Many of those people have pet algorithms or approaches that compete with existing deep learning. Finally, there are the pragmatists, plugging along the math, struggling with the messy data, scarce AI talent, and user acceptance. They are the least religious of the groups making prophecies about AI. They just know that it is hard. Given that the power of AI progresses hand in glove with the power of computational hardware, advances in computational capacity, such as better microchips or quantum computing, will set the stage for advances in AI. Now, speaking about quantum computing, machine learning and quantum computing are two technologies that have incredible potential in their own right. Now, researchers are bringing them together. The main goal is to achieve a so-called quantum advantage, where complex algorithms can be calculated significantly faster than the best classical supercomputers that we have today. This would be a game changer in the field of AI. Which school of thought on AI do you agree with? Would you like me to create a separate video on what happens when quantum computing and AI collide? Let me know in the comment section below. Thank you for watching. Cheers.